Good evening, folks. It's 10:32 p.m. I want to say this is Tuesday, December the something or other. Almost the end of December. We're into almost the new year, 2021. This is class number 2, session number 1 on advanced model rocket building. Oh, by the way, again, my name is Jason Wampler, the owner of a company called Wampler. We're designing, engineering, and building sounding rockets. And you see my 4 test subjects. On tonight's episode, we learn the exciting truth about how many things you need to gather together for supplies for your rockets. Hey folks, I want to make sure you understand something in no unclear terms. You have to have both a talent and a passion for building rockets to begin with. These classes are intended for everybody, but they're really focused on college students and working professionals who are in the aerospace industry, who want to better their skills and perhaps engage in building their own rockets. This class is class number 2. This is advanced model, I keep saying that, advanced rocket building, including sounding rockets and very, very small launch vehicles. And I got to tell you, just a side note, I'm working on the 4-motor monstrosity. It's going to be pushing about 15 feet, no taller than 15 feet. That's it on the... where my finger's pointing out right there, that tube right there. That's the upper body tube. It's going to have a nose cone. I'm thinking I want to put a long nose cone on, and no, I forgot it. I changed my short nose cone on the top. This is the motor section. I got to tell you, my good buddy Yuli, we're going to have to shoot during the daytime and not at night. I need Yuli to hold the camera. And you're actually going to see me in the picture. But the thing is about all the rockets we build, sounding rockets, they need to fly stable. They need to be built out of extraordinarily rugged materials, and their construction methods are going to be fairly complicated as well. The thing about this is, if you want to, I'm showing you the back profile. Let me turn the flash on so it really lights things up. There, that's better. Let's do things that way. Let me turn my headlight off because that's distracting me. When the Delta IV launch vehicle was launched, it had, one of the models had 6 motors surrounding the circumference of the base of the main trunk of the rocket itself. Now I come to find out there's variants of that design. Now this company in Tennessee is putting 3 booster motors on one side and 2 on the other. I swear, I can't comprehend that. It's not a bad idea. It's not a good idea. It's very, very odd. It's kind of like an aircraft with the fuselage offset, the wing plane, and a motor on one side and the cockpit on the other. I've never seen anything like it, but any idea is a good idea as long as it's well engineered. And it was the gentleman. He's leading up a company that builds rockets, full scale launch rockets, nothing to do with sounding rockets. And I'm going to get there as well myself, but like I said, you got to learn how to walk before you can run. But I got to tell you, the attachment methods for these external boosters on these rockets, not the pooper boosters where they tear away after the fuel is spent and they're recovered with their own separate parachute system. I'm not interested in that because it's too complex. But the other thing is, I don't like the idea. The entire booster motor section with the trunk that leads up to the payload section, it needs to be 2 separate parts. But it needs to be a single stage to orbit launch vehicle. And I'm also subscribing that too. I don't like staging. In fact, I kind of hate it. The Atlas V rocket, it's kind of ugly. It's ungainly. It's a history-making machine. It's one of the crowning achievements of mankind in this country, United States of America. But you know what? And I think the world of Wernher von Braun. He's a very brilliant man. And those F1 engines, they're literally the size of a small condominium, actually a large condominium or a small house. They're amazing. The F1 engine alone is an amazing technological feat. But honestly, I'm not entirely into liquid rocket motors just yet. I have to evolve to that point, and it's going to be a while, probably about another 5 or 10 years before I'm really into that. But here's the thing. The Saturn V rocket, I believe, had 5 different stages. And when you get into staging, it creates all sorts of complex circumstances. Everything's got to line up. The timing, microprocessors on the bottom sides of each stage, right next to the booster or the rocket motor's bell nozzles. And I just don't agree with the idea. I'm more of an SSTO kind of person. In fact, I insist on it. Strap on external boosters for all the rockets I do design with the nose cones canted inward, either a couple of half axis with 2 parallel long axis points of reference for calculating center of pressure, or 1 wide flat X for 1 long axis center line imaginary. We're calculating CG, not CG, CP, center of pressure. Now, I'm coming up with this stuff. I am an engineer, but my friend Jim Crilly, shout out to him. Jim Crilly is, he's older than I am. Him and I think alike, but he's just been doing it for a lot longer. So he thinks correctly. He has very little, if any, exposure to cars, and he doesn't touch rockets, but he claims I'm a hybrid monkey engineer. My association with him, it tends to help me to not so much what to think about, but how to think to begin with. And he's helping me out that. He's actually smarter than I am, and it only took me about 5 years to realize that. Anyway, thanks, Jim. But I've got to tell you, I tend to make things very, very challenging for myself, only because I'm not satisfied with status quo. I'm seeing all these amateur model rocket, amateur rocket organizations, and all they build is 1 long trunked rocket with a long nose cone and 4 fins. I got to tell you guys, less than exciting, less than impressive. When I get done with the 15-foot tall 4-motor monstrosity, I am going to sand it down, I am going to primer it, and I am going to paint it. I'm going to do it all myself, unless I can get my good friend Scott Faka. Shout out to Scott Faka and his girlfriend Diana Hyra in Buena Park, next to Fullerton. Scott, I got to get you off your bum. Stop working so hard for your other company. They're not paying you that much. When I get the funds, I'll pay you all the money you want. I need help with electronics. Please, I'm begging you, brother. Because electrical and electronics, they're not my strong suit. But anyway, so rockets are extraordinarily complicated. Now, this Roar engine monstrosity and the other 3 rockets I'm building, I mean, up to this point, I'm now into my 4th month getting to this point. And the 4-engine monstrosity is 15 feet tall. Guess what, guys? I've kind of made a shift in my mind about this. Sorry about that. There's a street cleaner in the background. I am outside, and I'm somewhat freezing, but that's okay. That slows down my talk and makes me stop becoming a motor mouth. Well, here's the thing. Guys, I got to tell you, team build exercises are fine, but when you get into teams of 30 and 40 people, you know what I think? I just think that's too many cooks trying to make the same pot of broth. Guys, you got to scale back. If it's a bunch of college students, like I shout out to some folks at USC, University of Southern California, and their efforts to build a rocket. But, guys, the same thing, man. I have some points of criticism for you. You have to have what's called RCHEI. I don't think I've invented it, but I developed it. It stands for remote control head end ignition. So you basically use what's called a model rocket. A model car, a remote control car controller, which has a wheel and a trigger on it, or you can use an model aircraft controller. But it's easier for the model car controller. Basically, it's a handle with a pistol grip and a trigger. And it comes with an antenna. That's a transmitter, and there's a receiver. It's wireless. I was watching this video about USC's accomplishments, and I had 3 contentions about it. Hey, you guys are great, but I've got some criticism for you. Break away from a single fuselage 4-fin rocket. They're glorious. But you know what? Everybody's doing that. You guys at USC, you're capable of so much more. So watch these videos. Hit the subscribe button. Again, okay, there's time number 1. That is gross. Again, my name is Jason Wampler. I own the company Wampler. Right now, we are building 4 different sounding rockets and sounding rocket prototypes, and they're a lot of fun, but my goodness, they're just incredibly complex undertakings 4 months into the project. But back to the subject of USC. Hey, you guys, break away from traditional rocket body styles. Get into something like what I'm doing and instructing on these videos. Again, hit the subscribe button. I'll monetize the site and start making some money off it. The second point of contention, gentlemen, in combination with weather on a playa, a flat plane, as explained before, I'm not a meteorologist, but I know what causes turbulence and high wind speeds on a flat plane. You got to time these things properly where the wind's not blowing. Early morning is the best time to launch. Otherwise, everything's going to get blown over and you're going to have to scrub the launch. And get rid of the wires. Everything needs to be by remote. Remote telemetry, a remote ignition, remote status checks. They're called the go no go, and you have to have a remote control. Not remote control. You have to have a command center. And if you do have to fly in semi-windy weather, don't take a tent. You're gonna have to take something that's a little more solid, like a breakdown shed, and you have to put seats in it. Everything's gonna have to be indoors, and you have to have a command center. Now, for now, I recommend you guys at USC stick to solid fuel rocket motors, which is what you're doing. That's smart. The third point of contention is, I saw the whole video, and what I wasn't impressed with at all, you guys slathered up the motor after before you inserted it in the motor tube, a single rocket motor with 4 fins. Well, it's basic, but you guys got to get on to more complex stuff. If you're going to get jobs in the rocket industry, and I'm just telling you. But whatever that red goop was, I believe it was some type of rubberized polymer that had a quick set time. You didn't install the motor. You slathered the motor up to slip it in. It's supposed to solidify so the motor doesn't fall at the bottom of the rocket. Hey, guys, just a suggestion. Instead of playing around with wet jelly and getting it all over your clothes, it looked really, really sloppy. It looked unprofessional. And it just is not appealing. There's something called an aft closure, AFT, and then CLOSURE. And NAR or Tripoli or Jacobs Rocketry, they'll get you set up with anything and everything you need. Get an issue of Sport Rocketry that's supported by National Association of Rocketry. It's a magazine. It's an actual physical magazine. It's a periodical every 2 months. And there's all sorts of ads for CNC machine shops that make and specialize in aft closures for high-powered rocketry and model rocketry. Now, the word model is kind of a stigma with me. There's no such thing as a model rocket because rockets aren't toys. But, you guys, you don't lather up the model rocket motor body with this stick quick and have to hope it holds in. It'll work, but it makes such a godforsaken mess, and you nearly have to tear the rocket body apart to get the silly stuff out. Now, look at model rockets and model rocket technology. It'll help you guys out greatly. I'll throw in one more point of contention, guys, and I'm not trying to pick on. I'm trying to help you. Scale down in the complexity of the materials of your rockets. It's slowing you down, and nobody's interested in materials engineering when they're trying to build something to scale that flies at altitude and is as complex as a rocket. Guys, you're loading yourself up. You're kind of going in the wrong direction with a lot of things. Watch my videos. Hit the subscribe button because I need the money, but I almost always do it for the spirit. Hey guys, watch, put on the center view. I'm aiming to go to school at the end of next year to get to begin my journey towards a PhD in mechanical engineering. And I got to tell you, watch these videos, it'll help. Now, I'm not the world's most successful rocket builder, and I got to tell you guys something else. I think I told you the last time I shot a video. Guess what? You folks at USC are brilliant. You kids are absolutely dynamic. And I call you kids. I'm 50 years old. I act like I'm 17. You guys are 20. You can all be my oldest children. I'm telling you, man. but they're not. That's why I'm just saying that because I call you kids. You kids are brilliant. You're motivated. You're driven. You work together. Two things about your arrangement need to change. Number one, you have to clean up your shop. It has to be well lit. It has to be spaced out more. If you're limited for space, go down, go up. You don't have to go outward. So think about adding some stories to your workspace or getting into a larger building. Spread things out. And number two, everything needs to be clean. It needs to be white. It needs to be very, very well lit. The reason being, you don't want to work in a clean room, but you want everything to be well lit and ventilated when you're building a rocket, because you're working with a lot of small parts that'll fall on the ground. You walk all over them, and in the dark, you can't really see what you're doing. It's a semi-dark, cramped work area. So see what you can do about changing that over a period of time. Just my suggestion. But I should talk. Look where I'm working at. I'm working on the back of my GMC pickup in the high school parking lot at Estancia High School in Costa Mesa, California. Whoopee. Well, my voice is still recovering. I had a minor case of laryngitis. It just scared the daylights out of me because I depend on my voice. Anyway, so this is a 4-engine monstrosity. This is the lower section of it. I measured it the other day. Yeah, it's going to be 14 to 15 feet tall, and I'm up in the ante on the weight. I got to tell you, well, 300 pounds is it, but I wouldn't be surprised if it's fully loaded and it weighs nearly 400 pounds. That's the biggest thing I've ever built in my entire life. So I'm asking myself the question, why is my reach exceeding my grasp? Well, I'm crazy. Boy, I know I'm telling you something real funny. Okay, I'm still alone. Ulysses Andrade, my bro, shout out to you. Ulysses, we're not going to do any more night shots because you want your nights off. I got to catch Ulysses in the morning, before he engages in his daily routine, but that's okay. Okay, now, here's what we're going to do. I'm simply going to rattle off several things you need. In the tool shop, we talked about the compressor and the generator and how you're going to have to segregate these tools, put them into another vehicle because you don't want your mobile manufacturing facility to go with you unless you have a trailer behind it towing your launch vehicles, your rockets or your sounding rockets. So if you take your mobile manufacturing facility with you, buy a $300 utility trailer from Harbor Freight, get it set up, get somebody to cut and carpet a couple of wooden saddles, bolt them to the trailer, tie everything down. Don't ever transfer your rockets the fins first, facing the front of the vehicle, and don't transfer the rockets in full length. You want to break them up in their halves, respective pieces. One thing I do want to commend you guys at USC for is your ideas for recovery machinery or recovery fasteners and the anchor points. You used quick release, quick lock climber's gear, and I don't do that. I actually use fixed point. The problem with my way of doing things is when you separate the two rocket halves, one end of the rocket is going to be facing forward, the other end is going to be facing backwards, because I hard attach the shock cord at both ends. I kind of believe in doing that, and then I bundle the length of the rocket cord and I tie it off with zip ties until I'm ready to load and launch. And the other thing I do is I use very, very lightweight baker's wrapping or bread wrapping to wrap up the parachute and the drogue parachute, and then I unwrap it, but I leave the parachute and the drogue folded. Then I take the zip tie off the shock cord and install everything. You have to install it a certain way, and you have to have flame-proof wadding that goes between the separation charge and the parachute and drogue assembly. My 15-foot tall 4-engine monstrosity. I got to tell you, folks, I was thinking about two 8.8-foot diameter parachutes and one drogue for each, about 12 inches diameter. The percentage of parabolic and the size of the spill hole and number of segments, I'm going to leave out up to a company. Now, you guys at USC and everybody else watching, up to a place called Top Flight. They custom manufacture all sorts of rocket parachutes and parachute systems. Now, I'm going to leave it up to them. I'm going to give them the specifications for the parachutes I want. I'm going with 3 6-foot diameter parachutes for my 15-foot tall 4-engine monstrosity. That's what I'm settling on. However, they're all going to have 3 10-inch. They're going to have 3 8-inch drogues. I think a 12-inch drogue is rather large. That's for more of a, like a 4 or 5 foot base launch vehicle itself. However, I'm going to leave it up to Top Flight, because another thing you guys have to realize, and you guys too at USC and everybody else around the planet who's going to watch this video, you can't do everything. Sometimes you have to sub things out. And I'm thinking right here, these are the 2 motor tubes on one side, starboard or port, because there's no top and bottom to a basketball. No, that's a joke. Wow, my friends are freezing too. Wow, how about that? Boy, it's really cold tonight. And this is California. What's going on? Okay. Again, I kind of really don't know where to start with explaining exactly how complicated designing and building a rocket is. It's incredible. I love it so much, but it's so staggeringly time-consuming and complicated. And friends, everybody watching in the rocket world, NAR, Tripoli, John Wickham Space Camp, USC Rocket Engineers program. I'm not sure what the program is called, but your video was excellent. I watched it on YouTube and I was very impressed. Anybody who wants to watch this, take some hints, from a 50-year-old man that's been building experimental rockets for about a little over 20 years. In building rockets, hey guys, I got to set you up for something. The biggest expense in building a rocket is always going to be the labor, the manpower to put things together. Materials, again, you want to steer away from excessively exotic materials and fabricating exotic materials. Because I got to tell you guys, that's really going to slow things down. You might want to consider getting closer to the finish line before you start that very, very long race. You can cut down a 100-mile race to 10 miles or even 5 miles. Cross the finish, be first across the finish illegally, but you won't break a sweat. The point is, the rockets I'm going to show you, and I got to tell you, I'm almost positive, I am positive, this is Schedule 40 ABS. It's foam core Schedule 40 ABS. Now, this is the part where I'm going to tell you something like, you got to go buy this stuff. Well, it's your choice. You can use Schedule 40 PVC or, PVC, I said that right. Green, jade, or white. Now, you got to be careful, though. Schedule 80 PVC in 4-inch diameter you can get from Lowe's. I don't really recommend that because the wall is too thin. The stuff crushes and bends and develops a memory. And the other thing is it doesn't drill too well. When you drill and you countersink holes in the side, you're going to run wood screws into hardened, cured, and heat-treated MDF, which I'm going to figure out how to do myself before I tell you how to do it, because there's nothing like generating a lawsuit because somebody tried some bunk advice of mine that wasn't tested, and they burned their kitchen or they burned their house down. I don't want that on my conscience, and that's no lie. Okay, but my goodness. I mean, I could talk for the next 2 hours on the proper approach to attaching these 2 rocket motor tubes together. But the long and short of it is, let's talk about a supply list. Hey guys, I'm not going to teach you how to, in this class, I'm not going to teach you how to build itty-bitty little rockets. I mean, I can do that all day long, and it's boring. It's just, because it's not challenging, it's just commonplace. 20 years ago, I built Estes and Quest model rocket motors. I even built, for my level 1 certification, I built a really nice kit from Aerotech. Aerotech, by the way, folks, is a company to watch. They're going to actually start getting into possibly into general commercial aerospace with regards to rockets, rocketry, sounding rockets, and launch vehicles. Aerotech, those guys are on the ball. Cesaroni Technologies has already taken off. They have like 2 locations. I admire them. Public Missiles, I don't really care for the name, but they do pretty well too. And they have a reputation. They've been around for a while in model rockets. My company, Wampler, I'm still trying to establish my reputation. To be honest with you, everything in aerospace, especially related to rockets, it's going to take a long time for your business to get off the ground. I'm a patient man. I make money by other means. I have another YouTube channel, but I don't want to talk about that. You can watch it. It's called Ground Level Psychology. It has nothing to do with rocketry, and that's tomorrow night at 9 p.m. That's Wednesday, 9 p.m., but I'm not plugging that. That's for an entirely different audience. Now, the materials you're going to need, aside from the tools I talked to you about, guys, I'm not going to teach you about anything smaller than a 4-inch diameter Schedule 40 ABS tube. A foam core ABS tube is fine. Solid core ABS tube is very, very heavy. It's very dense and it's incredibly strong. But the problem is, I can make the world's strongest aircraft and make it out of cast iron, and it'll never break. The problem is it's too heavy, it won't fly either. So you want to be careful about that. Keep your power to weight ratio in good range by using materials that are strong and light. However, again, as mentioned before, I'm warning you, get away from electro smelt weaved and vacuum bagging tubes, phenolic vacuum bagged with exotic fiberglasses. Leave that up to the companies that get government grants in excess of the billions of dollars, if that even happens anymore, and international rocket building companies, because they have the big bucks. Again, if you stick to simple, robust designs and simple, readily available materials, they do just fine. I was watching a video on YouTube the other night, and the guy built a 4-inch diameter 4-fin rocket. Again, I'm not impressed with that body style. It seemed to have good results, but it's just too conservative, and everybody does it. Do something else. Do something different. Push ahead of the pack. That's what I'm doing. But I do that I'm a natural at doing that. I've always stuck out like a sore thumb. Everybody hates me from time to time, but I get around and they show me love because they feel sorry for me, and that's no lie. But the thing is, this rocket is made out of, I don't know, 4-inch PVC, 4-inch diameter PVC, kind of the same stuff that I was talking about before that is available at Lowe's. He didn't expound on the technical details. It was kind of a documentary. This launch vehicle, it attained some insane altitude, something like 330,000 feet. And it actually, I may have let something go in orbit. It wasn't a satellite, but I don't remember. It showed part of the flight. Somehow that rocket attained escape velocity. For the space shuttle, that's 18,500 miles an hour. And I do believe it wasn't a night launch, but you can get fooled by it because by the time it got through the boost phase, it didn't apogee. It just left the planet's gravitational pull, the Earth's atmosphere, and went beyond high Earth orbit. 330,000 feet is way, way, way up. A mile is 5,284 or 82 feet. So you can divide that 330,000 by that number, and you can calculate how many miles up that is. That's insane. And he used PVC pipe. So now I feel 100% confident Schedule 40 ABS with foam core will do the trick for anything. I was worried about the friction from laminal flow at speeds of an excess of 1,000 miles an hour, which is very, very realistic for rockets these powerful. But then I saw that video. The guy used PVC tubing for an extraordinarily transonic, ultra high altitude rocket. Probably lost it in outer space. And he's using PVC. I'm using ABS that's a little bit lighter, and probably, I would almost say, about 2 or 3 times stronger. Laminar flow will generate some friction if it catches surface impurities. It will rip the paint off, so you make the rocket look really nice and pretty. One launch after that, and it's going to look like a disaster. So be prepared to sand it down, tear it apart, reprimer, repaint it, and fix it with new fasteners and guts. That's the folly of life. But in rocketry, or building rockets, launch vehicles, sounding rockets, or even hobby and model rockets, if you're doing it for fun, guess what? After every launch, you can't just go back to the pad and launch it a second time unless it's an ultra small kit. That just doesn't work that way anymore. So these large, dangerous rocket ships, these sounding rockets and launch vehicles, one of which I am building a launch vehicle, the 15-foot tall 4-engine monstrosity, is no longer a sounding rocket, it's an actual launch vehicle. So I'm just going to cut to the chase and say, look, guys, I don't build satellites, but I am open-minded about somebody approaching me about if they want my launch services at this point. And that being the case, it is going to take 2 years to finish all 4 rockets, and that's how it goes. Okay, Schedule 40 ABS, 3 inches in diameter for motor tubes, 4 inches in diameter for the main fuselage tubes, and guess what? You're going to have to kind of look hard for this. Home Depot does have 2-foot sections, a 6-inch Schedule 40 ABS. Here comes the street cleaner again. He's competing for your attention by making so much noise. And I can't talk any louder. Sorry about that. Now, let's see some other stuff you're going to need. These guys are what's called peg posters. They're wrought aluminum. And you need a tool, a rip saw to cut it, and a face saw to square up the edges. You need a couple of hammers. You need a pick. You need a tap. You need pliers, and we'll talk about that yesterday. But these are the construction mechanisms. These go down the center holes that fasten these tubes to that tube. And I gotta tell you guys, the most complex part of this building is the actual fuselage, not the internals and the electronics, but is actually figuring out how in the hell to attach these tubes to this tube. Now, smaller scale rockets, excuse me, I'm just clearing my voice. I swear I'm not intoxicated. I'm talking so fast. I'm talking. My mind is working faster than my lips. I'm exhausted and I have dry mouth because I haven't had anything to drink. I do that to myself. Guys do that to themselves. So put that peg post there. Anyway, it's a long story. Now, the other material you're gonna need. Excuse me. Oh my goodness. Now I have this. Oh my God, I gotta move this. Not a good place to set it. You know what I really need? I need a cradle or a tray. So let's add that to the list for the other class I teach. My goodness. You know, guys, if I had 4 arms, I wouldn't have these disasters. So I'm thinking if I move to another planet, I'll be in with a nice looking alien gal with 4 arms, and our children will have 4 arms, and everything will be well. And I can think about how I still want 4 arms. That story doesn't make any sense, but I want at least the 3rd arm growing out of the middle of my chest. It always seems like 2 things are happening. I never have enough workspace, horizontal workspace, and I need that 3rd arm growing out of the middle of my chest so I can grab something on one side, grab it on the other, and manage a tool in the middle arm. It sounds silly. Well, you're going to be asking for 3 arms when you start building rockets yourself. I guarantee it. Either that or you're working on cars. Okay, so why to take this off? Excuse me, that makes time number 2. And that is gross. I have to do that. I do have a phlegm problem. Okay, what am I looking for? Okay, I'm looking for one of those bulkhead discs to show you the material you're going to need for bulkheads. This is the stuff that's the most readily available. Where in the blue blazes is it? I always have to look for everything, and I don't have my glasses on. There you go. No, that's tape. That's not it. Oh, my goodness. You know what I think? Okay, I have 1 disc left. Do I have any disc left? No, I don't think I do. Well, how about that? I kind of barking up the wrong tree. Oh, no. Okay, oh, there they are. I'm sorry about that. These are used discs from a failed attempt to build the innards of a rocket that's no longer to be constructed, because I'm much more wild and less conservative about rocket science. This is a bulkhead disc. Now, when you cut, the tool you're going to need is called hole saws or circle saws. Home Depot has them. Harbor Freight does have some, but this is for a 4-inch diameter model rocket. I keep saying that. Doggone it. I got to remove the word model from my vocabulary. This is the bulkhead disc. Look at the size of that. I'm thinking maybe I should take off flash, kind of see the details of this. My camera's not flipping out. I am, and it's trying to keep up. And my camera's actually an inanimate object that's trying to keep me sane. This is used for another project. The hole is drilled out to 5/16. Now we're going to talk about 5/16 rod in a second here. Kind of scratched up a little bit, kind of banged up. This is for an internal stringer, spine stringer, for an electronics set. We'll explain that later in developing the stringers. And we're going to develop the method of construction, including what's called timing and logistics. You always want to build the fuselage, conceive, and build the fuselage for the rocket first. Let me turn flash back on. There you go. Which is this. And then do the internals. Because you waste 3 months on setting up the internals for an imaginary rocket. Guess what? You're going to attempt to do other stupid things like me, which is increase its length, put more motors on it, mount them in external tubes, and do that. That large green section right there I got for free from my guys over in Santa Ana. And it's a 6-inch section of jade PVC. and it's going to make this thing a 15-foot tall launch vehicle. Guys, I don't know what to tell you. In 2 years, I'm just going to do it. I'm just going to take the leap. I know I'm aggrandizing things and I'm delusional. I'm just going to make this an official prototype, actual launch vehicle, and not a sounding rocket, because you know what? The more I get into this, the more I realize how much I do know. That I'm not going to brag about anything I don't know or tell you things that I'm not capable of doing. I'm not delusional. I'm just very, very passionate and driven. And guys, I've been holding in this crap for a long time. But this is called MDF. Let me turn the flash back off. I kind of keep going through that. This is MDF. It's what it does is wood paper. It's not paper. It's wood pulp. So basically, it's micronic press board, but it's much cleaner. It cuts cleaner, it machines cleaner, it drills out cleaner. It's pre-preg. It's impregnated in the process of forming and shaping and pressing at high pressures with epoxy, resin, and binder that's reduced with a plasticizer that reduces epoxy resins and their binders. Keeps them from drying too soon, thins them out so they are in a more liquid state. You know what? Now I'm competing with shadow. Let me turn this light back on. Kind of doing this a lot. There you go. And God, my phone's having a hard time keeping up with me. Sorry about that. So that's it. This is a half-inch thick. Guys, I got to tell you, quarter-inch thick MDF, it's worthless. It's too thin. It has no structural strength. Half-inch for anything under 15 feet. And you want to go into 3/4 inch thick, anything over 15 feet. And in these complex rocket building classes, guys, sounding rockets will start out with up to 6 and 8 diameters. But this is a permanent, ongoing class. As soon as I get the facilities and the money, I'm going to get into rockets as big in diameter as 24 inches across. But I need to get a fixed mortar, brick and mortar shop. I have my eye on some property in Black Rock, Nevada, and Gerlach County. Excuse me. That I want to set up shop in. You can't have a mobile command center and build something taller than 15 feet. And I said that before. So you need sheets and sheets of half-inch MDF. Schedule 40 foam core ABS, and the model rocket motor tube is behind me. I got to put this back and then put that motor tube set back in its respective place. I got to finish attaching that thing tonight too. So there you go. This is that's one of the it's either a transition base or no, it's a transition base for the one of two rockets I'm building. A 2-engine rocket that's kind of right there. My finger's on, you can barely see it. In all honesty, I'm thinking that's going to be a launch vehicle too, only because the motors that are on it and its relative size, it's going to be a real hot rod. So I'll load it down with payload. These other 2 rockets will be sounding rockets. Sorry, that makes time number 3 in case you're counting. I am gross. I don't want to see that shot of my trash can. I threw out some baked beans because Stater Brothers always puts too much sugar in their baked beans, but I always want to buy them anyway, and I end up throwing half of them out. Don't waste food, people. Don't be like me. I'm a hypocrite. Anyway, okay, so that's that. Now, in addition to the tools, the facilities, the candy dish, the compressor, the AC generator for the outlet, the mobile light system. I love these lights. They run out of lights in about 4 hours, so you have to keep loading them up with AA batteries. Let's talk about other materials. And I got to go over here to my nose cone section. The nose cones are also transition bases to go between 2 different size fuselage from 4-inch to 6-inch. And I'm going to work that one out. So while I'm teaching, I'm probably going to be learning myself. And again, it's getting really cold and I'm getting very, very tired. So we're going to wrap this up. We're into 38 minutes, so the class is going long. There you go. Can you see all those automotive funnels? Guess what? Those are makeshift nose cones, long and short. 6-inch, 4-inch, 3-inch, 2-inch, etc., etc. The automotive funnels make great nose cones. All you have to do is know how to mount them and reinforce them. That's a real trick in itself. Transition bases and nose cones, nose cones with funnels, transition bases with funnels, whole lot of fun. I'm actually still engineering the details in my head. Anyway, what else was I going to say? Well, that's it. So those materials, nose cones. I forgot. We have to talk about the fasteners. The stringer set. Before we get into anything too advanced, all I want to show you is this stringer, which is a threaded rod that I got at Home Depot. Well, this is a section of that threaded rod, and boy, is it resistant. I really am at war with inanimate objects. This is an uneven. Well, no, look at that. I square cut the end when it focuses, and I put a chamfer on the end of it. So the thread leads into the nut. I actually invented that process. Well, I didn't invent it, but I created that process almost 20 years ago when I first started building rockets with a much smaller scale. 1-inch diameter rockets. They're just not doing the trick for me anymore. Threaded rod, 5/16, 8-18 is what you want. Even for the 15-foot tall rocket, and I'll tell you why. Anything over 4 inches in diameter, a 6-inch diameter rocket, is going to have what's called a 5-square stringer set with threaded rods, nuts, washers, and sleeving. And then you're going to lay a very thin layer of either phenolic or aluminum sheet that you're going to cut and fit and sand over that. So you need these threaded rods. That's the material you need. These guys are extruded anodized aluminum tubes. They're not that expensive. You get them from Industrial Metal Supply. Look Industrial Metal Supply up online. These are zip ties that hold them together. That supplies. This anodized extruded aluminum is seamless, which means there's no joining seam. It wasn't rolled in heat electrically tack welded long axis. This is one solid continuous tube that was created that way. Anodized extruded aluminum tubes. I gotta tell you, they're incredibly tough. They'll slow down your saw, throw a breaker switch. The material is almost stronger than stainless steel itself. In fact, it cuts slower than stainless. So I don't know, it might even be stronger than steel, but we'll figure that one out later. Tubes. This is the sleeving for those threaded rod. Some of this stuff I'm probably gonna end up throwing out because I won't need it. Steel sleeves for the steel threaded rods. You don't want to steer away from aluminum sleeving for the steel threaded rods, because aluminum tends to offset and compress, and you get a warped spine, internal spine / bulkhead section with trays and all that, and the section ends up being warped because it bends. You're gonna find out later when I show you how to start building the internals. Okay. So over here we have a limited amount of tools and equipment. This is sheet aluminum and tin. And this stuff I got from Industrial Metal Supply. That stuff there, those wide aluminum ribbons, those are used for shelving. This tin, you get electric snips, you cut that. Boy, I'm getting cold. And there's angle aluminum, if you can see that right down there. That's for fried surfaces for the fasteners. My glasses are steaming up, and it's not even hot. It's freezing cold. Guys, my body's really starting to shut down right now. It is extremely cold, and guess what? I'm extremely exhausted, and I'm so enthusiastic. Guys, I just want to show you one other thing. Actually, two other things, and I will conclude this video unless it times out on me, which I hate when it does that. This is a stringer section. This is actually this section here. If you can see this, I only have 2 hands and 2 arms, not 3, which I really would like. This section, it looks odd, but I'm gonna take this apart, circle saw everything, put 4 equally placed holes in it for long axis launch tube for launch prongs. And I'm gonna try and use this in the 4-inch, 15-foot tall monstrosity. However, it may not work. This is not, I don't know if it's going to work. I may end up putting this on another rocket that's shorter. It's for a 4-inch diameter body tube, and that's what this green jade monster has. But I just want to show you that. So, tonight is an intro to class number 2. I'm just showing you what you need. One last thing, and hopefully, hold on. Okay, I gotta beat this thing to the punch. This thing has attitude. And your fasteners in this gray toolbox, you need wood screws, you need nuts and bolts, you need washers, you need fender washers, and you need machine screws for mounting electronics. By the way, we're going to get into electronics as well, but that's a long ways off, and even I need help with that. I'm trying to get my dad involved. I won't name his name. He's a great guy. He's smart, twice as intelligent as I am. And Scott Faka. Come on, Scott. Help me out. Stop dragging your feet, dude. I really need you. I do have one assistant as well. His name is Ulysses Andrade. He's an excellent fabricator / machinist. Brilliant guy. But he's relaxing tonight. I don't want to drag him out away from his home at night because, I just want him to be his own self. So that's it, guys. That's the end of our class tonight. You need a trash can, but oh my God, that looks disgusting. It's trash. It should look disgusting. And there's that motor tube section I'm working on. In all honesty, I think I'm going to wrap it up and go home because I'm tired and I'm cold and I'm slurring my speech because I'm exhausted. I need to get something to drink, but I don't do that either. Okay, so that's the end of the class. My name is Jason Wampler. I'm the owner of Wampler. We're building sounding rockets and very, very small launch vehicles now. That's a new one. I'm evolving as we go along. And I'm a founder of Red Hell Rocket Society, a society that's mostly open to scientists, engineers, and college students pursuing the art of designing, building, and launching rockets. And it's open to everybody else too. But I want people who want to be scientists, designers, and engineers for rockets. That's what the club is mostly for. It's not a free-for-all, but you know what I mean. Okay? And like I said, this is class number 2, session number 1. It's going to be labeled as such. And that's it. So good night, folks. Everybody go off to La La Land. Keep yourself warm, safe, and comfortable. And get your sleep, because I never do any of that for myself. And I'm crazy. All right, good night.